Alright, so today's video is going to be a little bit different from what you guys normally see on YouTube when it comes to backpacking gear. Today I'm actually in the chem lab and I'm going to be testing out two fuels. I'm going to be testing out ethanol here and esbit. Got a couple of stoves today I want to test out. I'll be testing out these are both from Trail Designs. This is the 1210 stove that came with the Sidewinder system that I purchased, I think, back around maybe 2011. I've had the stove for maybe the last 8 years or so. I actually haven't really used the stove out in the field, but I want to get a sense of how it performs in the lab. The other stove I'll be testing out is my graham cracker stove from Trail Designs. This is an esbit stove. This is the esbit stove, the graham cracker right here. I think this weighs in right around 3 grams. You can see basically it's just a little support for your esbit cube. This thing's made out of titanium, and you can see that comparing the two, this is definitely a much lighter option. But I'm interested in testing out today how the two stoves perform in terms of how much energy we get out of the fuel and how efficient these stoves are. Yeah, let's go ahead and check them out. So the first thing I want to do is go ahead and throw these stoves on the scale. This is the 1210 stove from Trail Designs, and it weighs in right around 0.52 ounces, or 0.521435 ounces. That is 14.7825 grams, right around half an ounce. Next up we have the graham cracker stove from Trail Designs. You can see this one's a little bit, it's kind of seen better days. This one weighs in right at 3.3922 grams. All right, before you get started, I want to take a quick look at my stove setup, or my pot setup. This is my Evernew 900 milliliter pot, and you can see right there I've got my lid. This is essentially just a heavy duty piece of aluminum foil, and normally all this stuff just stays in my pot. What I'm using is the Sidewinder system from Trail Designs, which comes with the stove. Both of the two stoves I just showed you guys. Essentially it's a piece of titanium, and this is the pot stand as well as a windscreen. So let's go ahead and set it up. I'll add about 500 milliliters of water, and then we'll go ahead and burn off the esbit and the ethanol, and then we'll do some calculations. So let's go ahead and check it out. So just gone ahead and added 500 milliliters to this graduated cylinder right here, and go ahead and pour that water into the pot. Like so. So what I'll be doing is recording the initial temperature and the final temperature after all the fuel is burned off, and then we'll go ahead and calculate the energy that was released in the reaction. Alright guys, so this is the fuel that I'll be using for the test with the 1210 stove. This is ethanol right here. This is a 95% concentration, and I'm going to be adding 10 grams of this fuel, and I'm going to see how much energy I get out of the stove. Alright, it's pretty close to 10 grams. I get about 9.93 grams of ethanol here. The next thing I'm going to do is go ahead and measure the initial temperature of the water, and it's reading right at 22.7 degrees Celsius. The stove is now lit, and you can see that the temperature is rising. So we'll let it cook here for a few minutes until all the ethanol is burned off. We'll record our final temperature, then we'll go ahead and calculate the enthalpy of the reaction. Okay, so all the fuel is burned off, and you can see the temperature is right around 81 degrees. It actually went up to, I think, 83.8 degrees Celsius. So we'll go ahead and find our change in temperature, and then we will calculate the energy that was transferred from the stove into the water. Let's take a look at the calculations. This is the equation right here for energy in Q, and we're going to plug in the mass of the water. That was the thing that was being heated, and the specific heat of water, which is 4.18 joules per gram per degree Celsius. We also have the temperature change, delta T, and that is going to be the difference between our final temperature and our initial temperature. So let's go and take a look at the calculations. So Q equals to 500 grams of water. That was how much water we put in the pot. times the specific heat capacity of water right there. And we got 62.1 Celsius for our delta T, which gives us an energy output of 129,789 joules. So we'll go ahead and do the calculations and now convert that into enthalpy change and see what we get. This is the equation for the combustion of ethanol. So you can see that for 1 mole of ethanol, we are releasing 1,367 kilojoules per mole. That's a literature value right there. I just looked that up in a database online. And if you look over here, we have 9.9301 grams, and the molar mass of ethanol is 46.01 grams per mole, which gives us 0.2155 moles. Our equation right here for delta H, enthalpy change, is negative Q over N, which gives us an experimental value of negative 602 kilojoules per mole. The negative sign there just indicates that is an exothermic reaction, the energy is being released. But you can see that comparing the two numbers here, we are losing some heat to the environment. That's some systematic error there, but not really a big deal, because what we're really interested in is what we get right here. So now we'll go ahead and run the test with the esbit and compare results. This is the esbit that I'll be using for our experiment here. This is the, I think this is the 5-gram tablet, and this is the 4-gram tablet. You can buy these off of Amazon, I believe. I do prefer these smaller tablets instead of the 14-gram tablets. I think they actually smell a little bit less like fish and actually might be, I don't know, just easier to measure out. So let's go ahead and put these on the scale, and we're going to find the mass of the esbit here. So we have 8.4502 grams, which is just around the same mass as the ethanols. I'm going to go ahead and add a couple of drops of ethanol from this little bottle, so just to kind of get the esbit to light just a little bit easier. I've just added 500 milliliters of water into this pot here, and my initial temperature is 22.7 degrees Celsius. You can see the esbit is lit, so I'm going to go ahead and put the pot on there, and we will find our final temperature. Alright, so the esbit reaction is complete. The final temperature was 86.7 degrees Celsius, giving us a delta T of 64 degrees Celsius, and a heat output or energy release of 133,760 joules. We'll go ahead now and calculate our enthalpy change for the esbit, and then we will discuss our results. So we are back at the board and ready to do some more calculations. So we have our combustion reaction for esbit, also known as hexamethylene tetramine, and these are our products. I'm actually not sure exactly what all the products are in the reaction, but this is our literature value for the enthalpy of combustion, negative 4200 kilojoules per mole. And we plug this into our equation, divide the molar mass of esbit, and we get 0.06027 moles, and our delta H, or enthalpy of reaction, is negative 2,219.3 kilojoules per mole. Alright, so now we'll go ahead and summarize some of our results, and I'll let you guys know what I think about these two fuels. Alright, so let's end with a quick summary here. You can see that the esbit, I wanted to do the calculations in terms of kilojoules per gram of fuel, and I got 15.83 kilojoules per gram for the esbit, and 13.07 kilojoules per gram for the ethanol. That's 21% more energy for the esbit, so that is a win for the esbit. Another advantage of the esbit is that it is easier to carry. I personally use a Ziploc bag to transport my esbit, and you don't need an extra bottle or anything like that. You can also ship the esbit in the mail if you need to send it to a resupply point. Ethanol is a little bit more hard to transport. You have to have an extra bottle, and obviously it could spill, and that could cause some issues. What are some disadvantages of the esbit? Well, it's more expensive. The ethanol you can just buy in a big can from the hardware store, whereas esbit you have to order online typically. Another disadvantage of esbit is that it does smell like fish. If you guys have ever smelled esbit, it is not the most pleasant thing. Also leaves this residue on the bottom of your pot. You can see the bottom of the pot is covered with this dark gunk on the bottom that is kind of sticky, so that is a huge problem. But an advantage of the esbit is that it is lighter weight. Like I said, the esbit is more energy efficient 21% more energy efficient. And if you factor in the weight of the stove and the bottle for transport, it is the lighter option. All right, so those are my thoughts on esbit versus ethanol as a backpacking fuel. But I want to hear back from you guys, so post some comments down in the comment section below. Give me some feedback and let me know what you guys think, what you guys prefer. And also let me know if you want to see more videos like this in the lab. Definitely plan on doing more videos on backpacking gear. So stay tuned, guys, and I'll see you guys in the next video.